Hangzhou's Unitree and Shenzhen's Zhongqing Robotics are now in a head-to-head showdown from afar. Unitree has fielded its Kung Fu bodyguard, executing a set of boxing moves with fluid grace. Shenzhen's contender is the Zhongqing robot, which performed a hellishly difficult 360 degrees front flip with smooth, clean precision. Backflips were achieved long ago, so why is this front flip setting the market abuzz? Today, let's talk about what exactly makes a front flip so challenging for robots. Let's start with the core question. How can a robot precisely control 200 motion parameters across 12 joints while airborne? This involves several monumental difficulties not present in a backflip. Visual blind spots make it impossible to assess the landing environment. The forward shift in the center of gravity during a front flip makes a fall more likely. The ankle joints require immense instantaneous explosive power. The landing must be stable enough. A single front flip consumes 45% more energy than a backflip. So how did Zhongqing's engineers solve these problems? First, to tackle visual blind spots, the Zhongqing robot is equipped with a DJI 90 degrees downward-facing LiDAR on its shoulders, paired with a Huawei 5G module. This enables scanning ground protrusions in just 4 milliseconds, 15 times faster than human vision. Second, the ankle joints need to instantly generate 220 newtons-meters of torque, equivalent to lifting 2 motorcycles simultaneously. In this regard, the carbon fiber components co-developed by Zhongqing and AVIC Aviation, Industry Corporation of China, possess strength on par with military helicopter rotor blades, yet are 60% lighter than traditional metals. Coupled with Bosch's magnetorheological actuators, the joints can deliver peak torque within 0.03 seconds, transforming every leap into an elegant arc that defies gravity. Regarding landing control, when a 1.3-meter tall body plummets from a 1.2-meter height, the force difference between the toes and heels must be kept within 5%. That's akin to demanding someone jump from a second-story building in high heels and land steadily, a seemingly impossible requirement. Zhongqing's bionic hydraulic ankles are embedded with 32 pressure sensors. Working in concert with their proprietary swarm algorithm, they can perform 300 dynamic adjustments the instant they touch the ground. The simulation is so lifelike that a prosthetics company has even used this technology to allow users to regain the sensation of feeling grains of sand. From AVIC's carbon fiber materials to Bosch's precision hydraulics, from DJI's LiDAR to Cattle's Ningde solid-state high-density batteries, this seemingly simple front flip has driven technological upgrades across 12 industrial chains. The domestic adoption rate for core components has reached 81%, but if you think the front flip is purely a technological flex, you're underestimating its greater mission. The founder of Zhongqing has said, "Our robots are not porcelain dolls in a laboratory, they are warriors rolling through fire." Amid the flames of a chemical plant explosion, a Zhongqing robot performed a front flip over tilted hazardous chemical pipes and used its robotic arm to close a valve inaccessible to humans. On the embankments during the Yangtze River flood season, they continuously jumped to inspect 20 kilometers of critical sections. In the 2024 Shenzhen Mountain Fire Rescue, they executed 8 consecutive front flips to cross an 8-meter-wide cliff, leaving safety to the human firefighters. While other robots paint visions of entertainment and domestic bliss, Zhongqing has chosen a perilous technical path, charging ahead in industry and rescue operations. As they tumble and leap through ruins and flames, humanity's understanding of the preciousness of life is also elevated. For us, rather than comparing which child is superior, we should be grateful to have both Unitree and Zhongqing Robotics as twin pillars of excellence.